Hello and welcome to AI4. Our next session is led by Tao Ma. He is the VP of Language Technology Group at ASAPP. Please join me in welcoming Tao to the stage as he turns on his camera and starts sharing his screen. All right, it's all yours.
Thank you. Let me present. Thank you, everyone. It's an exciting opportunity to share my experience with speech recognition, the research, and the application in the contact centers with you today. As we all know, in the recent years, the booming of artificial intelligence and deep learning has really advanced the field of speech recognition and opened many interesting opportunities for the efficient improvement in the contact center. In today's talk, we will discuss some of the challenges of speech recognition technology for telephony audio, and we will present ASAP's latest research advancement, the Multistream convolutional neural network, and the self-attentive SRU, which topped the popular LibriSpeech speech recognition leaderboard. We will also share briefly some experience on how we productize a speech recognition research system for the contact center applications. So let's get started. ASAPP is an enterprise AI company headquartered in New York City. We are a startup started 6 years ago. Right now, we have about 300 people global-wide. What we do at ASAPP is we develop self-learning platform to empower the customer experience team, including both the digital agent, the voice agent, whether you are doing the care or you are doing the sales or the data analytics, through the whole interaction with a contact center, a customer with a contact center of the enterprise. We building AI self-learning platform to empower that and to improve efficiency, saving cost, and generate revenue. That's what we do. ASAPP is focused on the very large enterprises. For example, our current client and most our clients are the Fortune 500 companies, typical clients like JetBlue, Dish, Sprint. We got excellent feedback from those customers after they started using our product. A little bit about myself. I got my PhD degree in speech in 2010 in Mississippi State University. During my PhD study, I was the maintainer of a ASAP speech recognition engine. It's an open source speech engine. It's been there for a while. It's kind of the old school speech recognition system in the open source field. I was doing acoustic modeling research in my thesis. Also, I was doing the lots of programming and speech recognition optimizations, and contribute to the open source community, and working with the lots of industrial leaders and developers at that time. In some of my past experience before joining ASAPP, since like I spent 5.5 years at Apple Siri team as a founding member of the Siri speech team. The first few, together with a group of very talented researchers and engineers, we developed some state-of-the-art speech technologies and applied that to more than 70 languages and to empower Siri, the personal assistant from Apple. And some other experience like at GD.com, my team developed speech recognition, speech synthesis, natural language understanding, and dialogue technologies to empower GD's call center, which has 30,000 full-time voice agent for GD.com. And ASAP, I'm managing the language technology group. My group is really about how to the end-to-end converting from any research idea to a production code and a service in our product. It covers on the speech, natural language processing, machine learning, and data. So as many of you probably know that contact center interactions is a huge industry. Globally, every year, it's about several $100 billion involved. Among the interactions, how a customer interact with the contact center, about 90% interaction is through voice. It's through call. A customer will call a 800 number, talk to some voice agent. It first goes through RVR, then majority of the time will reach to a person to talk with. And 10% is about using chat, either through an app or through a web SDK, talk to a chat agent. After something worth mentioning is after COVID-19, we did observe a clear industrial trend. There's a more balance from the voice agent into the digital agents. So it's our view, and in the near future, probably like next 1 or 2 years, you will see more and more percentage on the digital channels and less on the voice channels. But this transition will be gradual, and it's take time. Speech recognition, it's been there for quite a while, and I would want to point out that telephony speech recognition compared with the traditional speech recognition on the smartphone and in the smart devices, these are very different. If we do a comparison that, for example, like the Apple Siri use cases, call my wife or send text message like Amazon Alexa, play a music. Those are more like one shot, and usually the utterance duration, the speech duration is quite short, and also the audio is recorded at high quality. We call it a wideband, usually like 16K sample rate. But for the telephony speech, it's very challenging. It's using narrowband. The sample rate is 8K. Also, if you consider the codec, there's usually voice IP codec heavily compressed. After the telephony channel impact, the audio usually becoming quite challenging. And regarding the conversation itself, a typical like Siri type of audio, maybe like 10 seconds or less than that, 5 seconds. But for the telephony speech recognition, it's 2-person conversation. In general, duration is like about slightly more than 10 minutes, like 12 minutes average. Like 2-person talking about many topics back and forth for like 12 minutes. And the degree of freedom of the topic and the challenging audio quality and the codec compression, many of these factors, it become making telephony speech recognition a very big challenge. In addition to that, usually you can easily see it's noisy speech. Sometimes when people are at home, the vacuum is running on, and on the busy street, they are on the call to a call center. Yeah. Regarding the speech recognition research and the benchmark comparisons, there are so many companies nowadays, universities are working on speech recognition. How can we compare a real different speech recognition systems from both research purpose and the production performance purpose? For the real industrial speech recognition applications, the best data for comparison would be the real production data. For example, if let's say internet company, a keyboard internet company, then the audio data, the best would be you get some real production audio recording, and you use that audio recording to compare different speech recognition system to see which system is more accurate. However, there's in practice, there are some challenges to do that. The audio recording in the call center usually is considered personal data. There's a privacy constraints. It's hard to do the compare with different speech recognition system without users' consent. That part really, it limited the usage of proprietary data for the performance benchmark comparison. Then there are some public corpuses. Some corpus, you need to pay certain amount of money, usually like several $1,000s. You can get some corpus, typically from Penn State University, the LDC. They have lots of different corpus like Wall Street Journal, that type of reading speech, and like switchboard feature is more of telephony, but in a very quiet environment. There's some call home, and there's some meeting corpus regarding the meeting recordings for comparison, but you need to pay to get that corpus and work on your research and do the comparisons. In the recent years, together with open source in the many software, we also started to have more and more free corpuses publicly available. A typical, the very popular one in the recent years are the LibriSpeech. And also there's TED Liam. TED Liam is the famous TED Talk, like public speaking in different topics. Those are also available as free. And there's a Workforge. There's also AI Shell. AI Shell is a Mandarin Chinese corpuses. It's also pretty large, about in the scale of 1,000 or 2,000 hours for audio. With these corpuses, the recent pretty popular one is to use LibriSpeech. It's very new. It's very large corpuses. It has 1,000 hours of audio. It's US English, and it's very popular among the researchers in the industry and in the universities as comparison purposes, kind of one of the a golden benchmark to compare different speech recognition systems. So then when we have that public available free corpus, we can compare different systems. LibriSpeech is a 1,000 hour audio recording from audiobooks. It started open source in 2015. So for example, like there's a leaderboard to see which system it have the best performance measured by word error rate. Word error rate is a measurement by word errors. It's the opposite of word accuracy. So for example, if I'm speaking 100 words, roughly if the speech recognition system made 2 errors, then the word error rate will be 2, and the word accuracy will be 98%. So for word error rate, it's the smaller, the better. From last year, 2019, Google AI blog published some recent, at that time, it's very big advancement regarding to get the best number for the LibriSpeech benchmark. And getting into the top, the #1 in the LibriSpeech leaderboard. Then there's some university, for example, Aachen University in Germany. They a few times they've been in very top places. Then Facebook Research and Facebook ML also published some papers using the LibriSpeech corpuses. ASAP, we started joining this leaderboard competition in 2019, and in our system, the first paper we published and in the speech recognition and the first system we attended this competition is the multi-stream self-attention with a dilated 1D convolution. We got that to the top for a short amount of time. Then some other company got better. And this year we are coming back in the 2020, and our latest paper, the Multistream Cnn with the self-attentive SRU, it made it to the top of the leaderboard, and without extra training data. So if we only use a LibriSpeech training data, we are the #1. If we add extra data, then there's some other comparisons. As a brief history, this is the LibriSpeech test set on the test clean. There are from 2019, there are like some popular number like 2.2, 2.3, 2.1, 1.9, 1.8, 1.7. You can see that competition pretty intense. The researchers in this whole world really working really hard to push the envelope of the state-of-the-art technologies, which benefit the whole world and the industry. This is the latest research system we developed, and it's accepted for Interspeech 2020 conference, which will be in October this year. In this research system, we call it ASAP ASR. It's using a hybrid architecture for speech recognition. When it's a hybrid, it means there is an acoustic model and there's a language model. We build a different model, then combine them together. We call it hybrid. On the acoustic model inside, we develop a new technology called Multistream CNN. The difference of the CNN and the Multistream CNN is we use multiple resolutions of processing. Each resolution, we call it a stream, and each stream has different resolution. We're using that to capture the different resolution of information and together to improve the acoustic model. On the language modeling side, we applied a new technology called Simple Recurrent Unit, SRU, and in specific, we use self-attentive SRU for this neural network language models. SRU is a new type of recurrent neural network compared to the most popular one like LSTM. It can be run in parallel regarding, it removes the dependencies of the state calculation. So you can run it, lots of computation can happen in parallel. So it can achieve similar performance with LSTM, but it runs much faster. In our result, we saw it as 10 times faster than the LSTM that could be optimized. So SRU is a technology invented by ASAP. Our researcher, together with some researchers from Google Brain, from Princeton University, from Cornell University, together we developed this new technology. And this new technology was published in 2018, and it has been more and more industrial applications started to using it. Some of the very top 4 high-tech companies, some used SRU in their production system. There's another technology called spectrum augmentation. This is developed by Google. We are using that in that research system, ASAP ASR. This is a new way of doing the data augmentation in the spectrogram domain, not in the frequency domain, in the spectrogram, not in the time domain. Due to the time limit, I will not cover the details of this. If you have interest, you can go to Google's AI blog, and in our papers, we also mentioned this technology because we use that. We also refer to it. So we talked a lot about the state-of-the-art speech recognition system. Then how to bridge the gap from a research system to an industrial production system for speech recognition. If we consider we can consider there are two categories of effort. One is from modeling perspective, the other from engineering perspective. On the modeling perspective, there are different models of performance need to be optimized to run in all kinds of neural networks. You need to develop the silence detection model and the confidence model, different text normalization, inverse normalization, punctuation, capitalization, and some reduction module to remove the sensitive critical number, SSN, etc. And on the engineering side, you need to really develop a highly available system, large scale, low latency to run in 24/7. This is non-trivial. Imagine typically a call center with 5,000 agents. Usually every day you need to process tens of thousands of hours of audio. You need to run speech recognition in real time. The real-time audio processing, streaming, and monitoring on-call services, Kubernetes, container, like deployment, scaling up, scaling down. There are lots of engineering challenges over there, but it can be done. So this is the brief content of my talk today, and thank you all for your attention. And if there's any questions, I'm happy to talk about that. Yeah. Thank you.
Awesome. A big virtual round of applause for Tao. Thank you so much for sharing your insight with us all. We really appreciate it.
Yeah.
All right, if you're looking for your next session, you can check the program page to find where you're headed next. Also, take some time to do some virtual networking. We'll see you around.
Thank you.